In this video, I'm going to talk about domain restrictions. And so we have here a function equation. It says, and the question is, what is the domain? Now, this is similar to, it's actually the exact same question I'm asking you when I ask for like the domain of the function when you see the function on a graph, or what's the domain of this relation. When you see it on the graph, you recognize that we have endpoints. Whoops, didn't mean to do that. You recognize that we have an endpoint here and an endpoint here. And so you say, what's the x-coordinate of this endpoint? Well, here it is, it's at A. And the x-coordinate of this endpoint is at B. And so we can say that x is in between A or B. Or we can write it in interval notation right there. So maybe what we should do then is graph this function, because it seems like the graph helps us find the domain. So if we graph this function right here, I'm going to show you in Desmos the graph of the function. This is what we get, and I zoomed out a little bit because it really helps you to see that this thing seems to be going on forever in this direction and this direction. Not only that, but it seems to be shooting up here right at 0. Now that's, that might not tell us everything we want to know, but it is a good start. That's actually a useful thing to look at this picture to get our mind thinking about what the domain would be. So we are, though, going to want to come back to this equation and work with it more directly. So whenever I ask you this question, what is the domain, and I'm not giving you the picture, or the picture is not something totally obvious for what the domain is, you can probably just assume that the domain is this. In other words, all real numbers. Okay, so the domain is going to be all real numbers unless we have some special reason to exclude certain values from that. Think about the set of all real numbers. All real numbers means everything. I'll go back to the graph. All real numbers means absolutely everything over the entire continuum, right? So it looks like the only value that maybe is not included in that is 0. I mean, maybe 0 is included. Maybe this branch of the graph eventually reaches to 0, or maybe this one eventually reaches to 0. I mean, it could be. I don't think any other value is in question, though. Everything other than 0 seems to be perfectly well covered. So that's what we have to think about when we look at our equation. Well, here's the deal. What happens if we put 0 in there? What is f of 0? Well, it's undefined, right? Because we simply cannot do this. We cannot do this because that is against the very definition of division. We can never divide by 0, right? So 0 is not allowed. So can't use 0. Okay. Can't use 0 there. Let me get rid of some of this mess. Okay, therefore, the domain is all real numbers except 0. So this is the basic idea. Start with the assumption that all real numbers are in the domain, and then think, is there something that we would have to exclude? Is there an exception? In this case, 0 is an exception. Okay. So let's think about one other situation. At least one other situation. What if we have f of x equals 7 over 20 minus x? Well, if we put 0 into this one, okay, 7 over 20 minus 0. Well, that's just 7 divided by 20, and that is a number. That's defined. That's perfectly valid. But the fact that this denominator could potentially equal 0, well, then maybe there is something excluded from the domain. And that, of course, is 20. Because if we put 20 in here, we've got 7 divided by 20 minus 20. 20 minus 20 is 0. And this is undefined again. Okay, so we would say the domain, all real numbers, except 20. Okay, one final example. If we had g of x is equal to the square root of, say, 3x minus 5. Okay, now, here 0, well, actually 0 would not be okay, but a lot of numbers would be. For example, 20, 6 would be okay, you know, just random numbers. But there is a bound, because if I put 0 in here, or if I put, say I put 1 in here, g of 1 equals square root of -2. This is also undefined because you cannot take the square root of a negative number. We'll talk more about that in the next unit. But this is another thing that we have to watch out for. Maybe you remember that from Algebra 1 or 2. You cannot take the square root of a negative. So, therefore, this radicand cannot be a negative value. So what basically the restriction we have for the domain is that 3x minus 5, the radicand here, must be positive or 0. It must be greater than 0 or equal to 0. And just to be, you know, just to be nice people, we should probably solve for x in this statement. So let's go ahead and do that. So this is the restriction on x itself. And this is how we could state our domain. The domain is all real numbers. Sorry about that. The domain is all real numbers greater than or equal to 5/3. So that, and what happens if I put, I can test that out. If I put 5/3 in there, I'd have 3 times 5/3 would be 5, and 5 minus 5 would be 0. So I'd have the square root of 0. Anything less than 5/3, I'd wind up with a negative value.